Good evening. My name is G. Rutvik. I'm from CSCC section. My ID number is 21951A05G2. Today we are going to see basic electrical engineering. My topic is a current sharing method for interface high frequency LLC converter with partial energy processing. There are two distinct reasons to connect power supplies in parallel: current sharing and redundancy. Combining of these reasons is common and there are many ways to implement them. The unique consideration of paralleling deal mostly with the outputs of supplies, electrical and mechanical. The first step is to clearly identify the all of the objectives behind the intent to parallel. There are several segments of the electronics industry that are often associated with power supplies used in parallel for power and redundancy. They are telecommunications, mass storage area networks, real-time computers, and public safety systems. Below are common terms used when discussing power supply used in parallel. Current sharing refers to the division of the load among the supplies connected in parallel. The supplies will provide differing portions of the load by default unless measures are taken to balance the load. Current sharing is desirable for three reasons. It increases the total amount of load current available. It provides duration for the individual supplies, helping improve their potential long-term reliability. It minimizes the potential for power bus glitches after a power supply has failed. In many redundant power supply applications, the supplies are carefully selected and implemented to provide both redundancy and current sharing. Doing so provides fault tolerance and duration to improve the longevity of all the supplies. Additionally, sharing of the load keeps all supplies awake and conducting current. An ideal power supply takes longer to come up to nominal output voltage. This could cause an unacceptable glitch on the power bus. Fault tolerance. The goal of protecting a system from any single point of failure. In some systems, multiple points of failure. The term can refer to simple paralleling or high-tech power systems using redundant AC phases, battery backup, N plus one hot swap power supplies, and remote visuals, and audible alarms. In this case, redundant AC phases, there are two power supply sections or drawers using separate AC phases. SPI has a great deal of experience designing fault tolerant power systems. Contact us directly to discuss a particular application. We can provide any piece or all of the required power system hardware. Hot swap used in most N plus one applications mounted in a rack. The individual supplies features front panels, handles, guides, and live insertion connectors for all electrical connections. The individual supplies can be inserted or removed without powering the system down. This is single phase equivalent circuit. This is three phase interleaving LLC converter. Isolation diodes, also called O-ring or blocking diodes. These are used for primary reasons to prevent a failed supply from causing a general system shutdown in a fault condition. The diodes in a failed supply will block the current of good supplies from conducting into the field supply without the diodes. The good supplies could see a short circuit condition. The system power will be lost. When a power supply is inserted live into a system already powered up, its output capacitors will otherwise drain power from the power bus, causing a disturbance. N plus 1 redundancy. N equals the number of power supplies required for the load current. One is an extra supply providing redundancy should one of the N supplies fail. Parallel connection. Connecting the plus and minus outputs leads of multiple supplies to the same respective points on a load. This increases the current available to the load but not the voltage. Serial connections as the opposite effect. Redundancy. The use of an extra supply provided as a backup used heavily in the telecommunications industry where system downtime is unacceptable. Power supply redundancy is a basic method used to create fault tolerance in a power system. Note that the term warm swap has been gaining acceptance. It refers to the scenario where the power supplies have a front panel on off switch on or an AC connector. The supplies can be switched on the after insertion. This will eliminate pin to socket arching when that is a concern. Even using power connectors that are safety agency provided for hot swapping, arching is generally not a concern. It is important to check if the hot swap power supplies under consideration have connectors that are safety agency approved specifically for hot swapping. If not, the power supply model should incorporate the on-off switch. Also be sure to check the maximum pin current ratings from the individual safety agencies. Current sharing methods. There are three common ways to connect power supplies in parallel for this purpose of current sharing and redundancy. Brute force, forced zero wire. Was also known as active or third wire current sharing. Zero wire, also known as drop regulation, passive current sharing, slope programming. Each method is unique from the others and has advantages and disadvantages of the which the power systems designer should be well aware. Switching power provides standard and custom products as well as support for all three types of current sharing. Brute force current sharing. The simplest implementation possible. Brute force paralleling connects two or more supplies together at the load with no additional circuitry used to create balanced loading among the supplies in parallel. The method can be used to increase the power available beyond that which one power supply can provide, and it can also provide redundancy. The unit with the highest output voltage conducts current first in order to create the greatest possible degree of sharing. The user must set the output voltages as closely as possible and try to match the impedance from each supply to load. Isolation diodes can be used. Pros and cons of brute Pros and cons of brute current sharing for method. Pros: flexible, scalable, inexpensive, ordinary power supplies can be used. Cons: requires precision adjustments of output voltages to achieve current sharing. The output wire length, gauge, and connections must be closely matched. The highest set supply will conduct a greater portion of the load current causing reduced longevity for itself. This can also cause power bus glitches if the lower set supply is conducting too little when its load is stepped up quickly. This could occur if the higher set supply experience a failure. The current limit set points should be reached to 90 to 100% of the rated output to reduce the potential for overstressing the individual supplies. Remote sensing cannot be used. The lower set supply will sense the higher set supplies output voltage, interpreting this as its own output voltage. The lower set supply will shut down by closing its duty cycle. Next, force the current sharing. This method uses active circuitry to measure a power supply's output current and compare it to the outputs from the other parallel supplies. A communications link called the third wire connects the supplies to one another. Active current sharing circuitry provides feedback to the supplies pulse with modulators adjusting their output voltages. There are many methods power supply manufacturers can choose from the feedback and adjust the current sharing ratios. This makes it difficult for power supplies from different manufacturers to do current share together generally. Doing so is considered impractical. Pros and cons of forced current sharing. Pros: shares load evenly. Voltage regulations can be within plus or minus 1%. The tightest of the three basic methods. Good power system scalability precede a most high-tech method. Remote sensing possible. No adjustments required. Cons: single fault potential. Although a rare occurrence, the failure of the communications link, the third wire, could, could cause a general power system failure. Complexity is greater, more expensive, not practical to match with supplies from other vendors or series. The current share bus, the third wire, may require external noise reduction components. System noise can interfere with the power system's behavior. Next, zero wire current sharing. This is a simple and reliable method of current sharing circuitry in the power supply measures its own output current and programs the output voltage up or down as the load to a supply increases. Its output voltage decreases linearly. In a two supply system, for example, the supply with the higher output voltage will conduct first. Once its voltage is programmed down to a point at which its voltage is the same as the other supply, they will both conduct current evenly. Individual suppliers do not know the existence of any other supply sharing the load current. They only react to the percentage of full load being drawn from them. Remote sensing should be utilized to maximize load regulations. Pros and cons of zero wire current sharing. Pros: good load balancing, inexpensive, reliable, best fault tolerance, excellent scalability, multiple sources possible, remote sensing possible, no adjustments required. Cons: voltage regulation plus or minus 2% could be perceived as lower tech. Please contact switching power for additional information regarding the methods of sharing for power and redundancy. We would like to participate in your process, helping to make certain their power system is optimized. Thank you for giving this opportunity.